We can also use Desmos to help us solve trig functions. Now remember, when we're dealing with trig, we could be working with angles in radians or degrees. We hit this little wrench over here to toggle back and forth between the two. So let's see what we can do here. If we have the first question, sine of A equals 1/4, what's the value of cosine B? And we have a right triangle ABC, where C is a right angle, and sine of A equals 1/4. So it might be worthwhile to just get a quick sketch in of what we're working with. So the sine of A and the value of cosine of B, where C is a right angle. Cool. So B is basically just this complementary angle with regard to A. So if we want to do the sine of A equals 1/4, we can find the angle by doing the inverse sine 1/4, and the angle is about 14.477. Now we know that the cosine of B, that's the cosine of the other angle in our right triangle, so that's going to be a complementary angle. So we could do 90 minus 14.477512, close enough. And then we could just take the cosine of this value. And that gets us 0.249999, or 0.25, which is 1/4. And yes, that is the theorem that when we're being tested on complementary angles, the sine equals the cosine. Same deal over here. Angle C is a right angle, and sine of A equals 0.70. So we could do the same thing. 0.70. And that's 40.422. So we could do this over here. 44.427. And we'll just call it a day there. 0.69999, or 0.7 again, basically. Now keep in mind, when we're dealing with pi, we're probably being tested on radians. So if we wanted to find the sine of 3 pi over 4, we have to convert into radians. So we could do our little wrench over here, change to radians, sine of 3, and then just type in pi over 4, and we get 0.70. And so when we get 0.70 over here, we need to figure out what that would match up with. A and B are both negative values, so not worth looking into those. And then we have C, which is root 2 over 2. So we just type in square root 2 and divide that by 2. And that does equal the same thing, so our answer would be C. One more question for us. If the cosine of AOB is negative 1/2, so now we're dealing with negatives. Again, we can use our inverse trig functions. So we can quickly get inverse cosine negative 1/2, and we're going to have to change that back into degrees for now. So in degrees, that's an 120-degree angle. So if the cosine of AOB is negative 1/2, what is the measure in radians of AOB? Well, angle AOB is 120. And remember, to convert from degrees to radians, we just multiply by pi over 180. So times pi over 180, which is 2.09. And we'd figure out which is equivalent to that. So 2 pi over 3, which does happen to be our answer here. Answer choice C does match up.